This lesson helps you understand quadratic functions. In a previous lesson, you graphed these two functions, x squared plus 4x minus 5, and negative x squared plus 6x minus 11. The first thing you notice is that the graphs of quadratic functions are smooth, arc-shaped curves called parabolas. The graph on the left opens up, and the lowest point on the graph is the vertex. The graph on the right opens down, and the highest point on the graph is the vertex. Next, whether the graph opens up or down depends upon the sign of the leading term, the quadratic term. On the left, the leading term is positive, so it makes sense that the values of the function would increase and the graph curves upward. On the right, the leading term is negative, so it makes sense that the values for the function would decrease and the graph curves downward. So if the leading term of the quadratic function is positive, the graph opens up. If the leading term is negative, the graph opens down. The next thing to notice about parabolas is their symmetry. If you draw a vertical line through the vertex, it divides the graph exactly in half. This line is called the axis of symmetry. This is useful because if you can find a point on one side of the graph, you automatically have a point on the other side. For example, notice that this point is 2 units to the right of the axis. So you know there must be another point 2 units to the left. Over here, this point is 3 units to the left of the axis. So you know there must be another point 3 units to the right. You can find the location of the axis of symmetry with a simple formula. For the quadratic function ax squared plus bx plus c, the equation of the axis of symmetry is given by the formula x equal negative b over 2a, where a is the leading coefficient and b is the linear coefficient. For the function on the left, x equal negative b over 2a is negative 4 over 2 times 1, which is equal to negative 2. And you can see this is the vertical line x equal negative 2. For the function on the right, x equal negative b over 2a is negative 6 over 2 times negative 1, which is equal to 3. And you can see this is the vertical line x equal negative 3. You'll learn more about the formula for the axis of symmetry in a later lesson. Finally, the y-intercept is an easy point to locate. It's the constant term of the function. On the left, the y-intercept is 0, negative 5. And the constant term is negative 5. On the right, the y-intercept is 0, negative 11. And the constant term is negative 11. This is easy to understand. Notice the x-coordinate of the y-intercept is 0. It's a point on the graph where x is equal to 0. So to find the y-intercept, evaluate the function for x equals 0. This makes the quadratic and linear terms equal to 0, and y is equal to the constant term. So the y-intercept of the graph is always equal to the constant term of the equation. Now that you understand some important characteristics of quadratic functions, you are ready to learn to graph them. This lesson has been brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.